Part 2 of our current electricity lectures about safety, production of electricity and costs. Electrical dangers. Well, overloading a circuit is a problem. If you keep adding high-powered appliances, like say a kettle and a stove and a heater and a steam iron, you can overload the circuit. The current in this part gets too high, and that can be a fire hazard. So to protect the circuit, you have a fuse or a circuit breaker inserted in series. So this could represent a little circuit breaker at your distribution board. Other problems are short circuits and loose wires that can cause sparking. So how does a fuse work? Well, it melts. Okay, here are some designs. This one is typically what you find in a car, 10 amp limit. And inside the plastic between these two pins, we have a little piece of wire. And if the current gets too big, it fuses. And we mean that it melts, it breaks the circuit. And as I said, it's caused by either short circuits, loose wires, or overloading. A circuit breaker, like a fuse, breaks the circuit. A circuit breaker, like a fuse, breaks the circuit. But it doesn't melt. It has an electromagnet inside. And as the current increases, it gets to the point where the magnet's strong enough to switch it off. And here we see a whole row of circuit breakers in the DB board, the distribution board. Another safety feature is the third prong in a three-prong plug. So we expect you to know how to wire one. The live wire, the brown one, is on the right-hand side, and the blue one, the neutral wire, is on the left-hand side when looking at it from behind. Usually there's an N and an L that is punched into the plastic to remind you which ones to do, but it's the third wire, the third prong, the green and yellow earth wire, that is the safety feature. So imagine that one of these wires, the live or the neutral wire, touches the body of an appliance, the metal body of the fridge. Well, then you would get a shock. So the earth wire is connected to the body of the appliance. And if one of these comes loose, then the current will travel through the earth wire, and even the smallest current of 50 milliamps will trip the earth leakage. And you can always tell which one it is because it has the little tester button on it. Power production. Well, in South Africa, most of ours are coal burning. So the coal comes into the furnace, and there's a boiler where there's water in pipes. It gets heated until superheated steam comes shooting out of these pipes to drive the turbines, which are a whole row of propellers, and they are attached to a generator, and that creates the electricity. So we're always interested in energy. How has the energy been transformed from the chemical potential energy in the coal to the heat in the steam, which then is moving. The kinetic energy of the steam turns the turbine, which turns the generator, which then converts it into electrical energy. It's then transformed and sent via the transmission lines out to the rest of the country. This is representing a nuclear power station. Nuclear power. So here we have the nuclear reactor. It uses a nuclear reaction to make the heat, which makes the steam, which drives the turbine and the generator, and the rest of it is the same as before. There's Koeberg, South Africa's only nuclear power station, in the foreground, with Table Mountain in the background. So it's about 50 km outside of the center of Cape Town. The nuclear reaction is what we call nuclear fission. Our fuel is uranium-235, which is a type of uranium isotope. It's a type of atom, and it's unstable. So if we shoot a neutron at it, it goes through the electron clouds, the layers, and when it hits the nucleus, it splits the nucleus into two smaller atoms, generating a lot of energy. But in the process, it produces 3 more neutrons, and they can go on and strike others. A small amount, only 1 kilogram of uranium-235 can make the same amount of electricity as 3 million kilograms of coal, and without the CO2, the carbon dioxide emissions. So at first glance, this is very attractive, but it's high risk, because if things go wrong, you don't want that. And there's long-term radioactive waste, which won't go away. The risk is the chain reaction. And if we're not careful, the splitting keeps happening, and in a very short space of time, in a matter of a few seconds, you can get a runaway chain reaction, which is a nuclear explosion. And that's what happened in Chernobyl, however you say it, in Russia in 1986. And that was largely human error and ignoring the safety warnings that were given. And then more recently in Japan, when a tsunami caused by an earthquake hit the power station, and it caused a huge problem, and they had to evacuate a whole city. Peaking generators, what is that? Well, during peak time in the evenings, when everyone's cooking and there's a high demand for electricity, the municipalities switch on diesel engines to drive generators. But it's very costly, costing between 6 and 8 rand per unit, being the kilowatt hour. Hydroelectricity is the best, but we don't have enough big rivers to have hydroelectricity. But at some of our bigger dams, we have what they call the pumped storage system. So how does that work? Well, during peak times, the water is allowed to flow down, turning the turbines making the electricity as before to a reservoir lower down. And later on, when it's off-peak times, when there's low demand and a surplus of electricity, the excess electricity is used to pump the water back up. What a good idea, because it's then ready to flow again. Renewable energy. Well, we know about solar panels, and Elec, our school, saves 100,000 Rand a month because of our solar panels. And then there's Jeffreys Bay, which has a large array of wind turbines. The biggest solar array in South Africa is in the Northern Cape near a small town called Kenhardt. As you can see, there's nothing around, it's just desert. Well, this is very good use of space. And the one preceding that, a little bit smaller, is the one that they first set up in just outside a little town called Daar. And they rent the space from a farmer. He used to farm goats and sell mohair, and on a hectare, which is equivalent to 2 rugby fields, he was earning about 150 Rand a year. He had to have a very big farm. Now they pay him 1,500 Rand a year per hectare. He's earning 10 times more, and he's not even farming. Power. Power is measured in watts, and it's how quickly we convert energy. So it's the rate of converting energy is called power. So if I multiply this equation by time on both sides, I end up with energy is equal to power times time. And there we use the unit of joule, but it's a very small value. And we buy electricity not in joules, but kilowatt hours. So let's think about that. A kilowatt is 1,000 watts, and an hour is 60 times 60 seconds, 3,600, and that gives us 3.6 million joules. So 1 unit of electricity is 3.6 million joules. The price in South Africa, as per September 2025, is 3 Rand 48 for the first 300 kilowatt hours. So it's that price per unit for the first 300, but it's on a sliding scale. If you use more than 300, the next 200 cost 4 Rand 18 per unit, and after that it's even more expensive at 4 Rand 58. Calculating the cost of using an appliance, we use that formula. So let's do 3 examples. Calculate the cost of operating a 2000 watt kettle for 20 minutes if electricity costs the lower rate of 3 Rand 48 per unit. So there's our formula again. Well, 2000 watts is 2 kilowatts, and 20 minutes is a fraction of an hour. So you divide by the 60 minutes in an hour, and you end up with that time times the price per unit, and that gives us 2 Rand 32. Let's do another. Let's consider a 5 kilowatt stove, and let's say it takes you 90 minutes to cook your meal, and you do this each day for a month of 30 days with the cost still at the lower price. Let's see what that costs. Well, we got 5 kilowatts. Now 90 minutes is an hour and a half, 1,5. Well, 90 divided by 60 is 1,5 times 30 days times that price, and we see it's quite pricey, 783 Rand for the month. And finally, let's do the same for a geyser. Understand your geyser is controlled by a thermostat, so it switches on and off. It switches on when you've used the hot water, and when it reaches the right temperature, it switches off. So let's consider a 3000 watt geyser, which is typical, that switches on 5 hours a day, which is also normal. What will it cost for a month? That's 30 days at that same cheaper price. Well, there's our formula. 3000 watts is 3 kilowatts times 5 hours for 30 days, and we end up with a huge cost of 1,500 Rand per month, 1,566 Rand per month. So, what are the expensive appliances? The high-powered ones are the ones that make hot. A geyser is typically 3,000 or more. A kettle is typically around 2,000 watts. A stove with an oven, and if you're using all the plates in the oven, it could be anything between 8,000 and 12,000. Very high powered. And a steam iron, typically in that range. The next on the list are those that make cold. So that would include your fridge and your freezer. So, how do we save electricity? How do we save money? Well, your geyser can typically be 50% of the electricity bill. Turn your thermostat down. It could be as high as 70 degrees. Well, that will scald you. It's so hot. So why pay to heat the water if you're just going to go and add cold water when you shower? Turn it down to 50 degrees. You will save money. Take short showers. Every time you shower, cold water runs into the geyser. The thermostat wakes up and it switches it back on again. So have shorter showers. And don't use heaters. Okay? Nelson Mandela Bay is a mild climate. We don't get sub-zero. Wear warm clothes. That's it so far. I hope you found it useful. And please remember to like and subscribe.